evaluating an exponential function that models a real-world situation. To solve this sort of a problem, we need three things. We need a real-world situation, we need an exponential function that models the situation, and we need a calculator. So let's grab a situation. The radioactive isotope uranium-240 has a half-life of 14 hours. The amount of a sample remaining in grams after t hours is given by the function a of t equals 1,500 times 1/2 raised to the t over 14 power. And we're looking for the amount of uranium-240 that was initially there and the amount remaining after 32 hours. So let me go ahead and copy this formula onto a clean page. And we'll remember that we need the amount initially there and we need the amount that was remaining after 32 hours. The amount that was initially in the sample is the amount remaining when no time has passed. So we can think of that as A of 0. Substitute in 0 for t. 0 divided by 14 is still 0. And then remembering properties of exponents, anything raised to the 0 power is always 1. So initially, there must have been 1,500 grams of uranium-240 in this sample. After 32 hours, well, t is the time in hours, and it's always worth double checking. I'm not going to try to throw you off with that sort of thing. If I'm talking about t measured in hours, I'm going to give you numbers that are in hours. But always check that because outside of the classroom, you never know what's going to happen. So the amount remaining after 32 hours is A of 32. And for this one, we can simply grab a calculator and go from here. So here's my calculator. And if I want to punch this in, I have 1,500 times, opening parenthesis, 1/2, which I'll punch in as 1 divided by 2. Raised to the power is generally a caret-looking symbol here. And then there's stuff going on in the exponents, so I'll use parentheses to talk about that. It's 32 divided by 14. Close the parentheses up there, hit enter, and my calculator is happy to tell me that there are 307.625-ish grams remaining. I'll round that and call it 307.6 grams. Just to give you a different perspective, here's a different calculator. And I like showing this calculator because it has some pretty print features. And using this calculator, my fraction looks like a fraction. Oops, wrong button. Sorry about that. And my exponent looks like an exponent. It gives you the same value here, and we're in good shape. There are certainly many different kinds of calculators, but most of them are going to fall into one of those two broad categories of how to punch things into the calculator.